Hello and welcome back to Physical Science Online. Today we're going to try to get through the waves notes. I'm always optimistic. I'm hoping one, so that probably means two videos. We'll see where we end up though as we talk about waves, waves that we need to know about. Yeah, so let's get going. First off, let's start with what is a wave? You probably, as soon as I say the word wave, some of you might be thinking about waves in the ocean. Some of you might be thinking about sound waves. Some of you might even know that light waves are a thing. But what is a wave then? If there's so many different types of waves, what is a wave? Well, real simple. It's a disturbance that carries energy through matter or space. So a wave, don't care if it's in the ocean, if you've been in one of those wave pools before, you've felt the energy. If you're hearing sound waves right now, it's because the energy is going from the voice or the computer, since it's recorded, into your ears, and then it's converted from mechanical into neural stuff. Energy is what's really happening. We'll talk a lot about energy in the next unit, but for today, a disturbance that carries energy. It has to carry something that usually carries it through matter or space. So a medium is if you carry it through matter. We'd say a medium is something that can be carried such as air, earth, or water, solid, liquid, and gas. If we're just carrying through space, then there is no medium. Because space, we've struggled with this a little bit in this class already. Space is the lack of anything. That's what space is. The vacuum of space is when there's nothing there. It's just emptiness that matter and energy can move through. Okay. Now we got an intro. Let's look at some examples here. So waves are basically split into two categories. On the left side of your screen are things that require a medium. Those are called mechanical waves. And there's stuff such as sound, ocean, seismic waves, stuff like that. They require a medium. They cannot travel through space. And then there's another form of waves that can travel through space. They do not require that medium. They don't require a solid, liquid, or gas to move through. And those are called electromagnetic waves. Hopefully you've heard of some, if not all of these before. Radio waves, microwaves, infrared, visible light, UV, X-ray, and gamma are how we break down the electromagnetic spectrum is what it's called, the electromagnetic spectrum. We'll get a little bit more on electromagnetic spectrum yet during class. And more or less, not quite the end-all be-all, because there's a lot going on with waves, but more or less, mechanical waves are usually longitudinal waves, whereas electromagnetic are usually transverse. And here's the big difference. Longitudinal wave kind of travels back and forth. It's kind of like if you pushed on some jello or something, how the wave would go all the way through it, and then maybe bounce off something and come back. So there's these areas of compression and rarefaction. Compression is when they're close together. Rarefaction is when they're far apart. We'll do a demo on that with springs in class. So that's a longitudinal wave. Think of it moving longitudinally along the axes. Transverse waves, on the other, are the stereotypical wavy waves that we see with a crest and a trough, and then we can calculate stuff like wavelength, the distance between two crests, or amplitude, the distance from the resting point, the center, to the peak, to the crest, or to the trough. So those are what the difference between those two are. That is a big focus of this unit. Make sure you know this diagram really well and the difference between these two types of waves. Speed of waves. Speed can be greatly changed for longitudinal waves. For mechanical waves, I shouldn't say longitude. For mechanical waves, the speed can really change based on the medium. So based on what something is running through can change the speed at which that wave travels. I see on my little thing that I'm running short on time. As I envision, there's going to be two videos, so watch for video number 2. This is where I'll end this one, so I know where to start up the second one. See you soon.